In this video, I'll show you how to solve the ALEKS problem called calculating and using the molar mass of diatomic elements. There are two versions of this problem. I am going to show you how to solve both versions of the problem. In this version, you are starting with a specific number of moles of a substance, and the problem wants you to convert that moles into grams. Now, the problem is going to give you the name of the molecule that you're working with. It's not going to give you the molecular formula, so part of the challenge of this problem is figuring out the molecular formula. However, this problem, all of the molecules in this problem are going to be diatomic elements. Diatomic meaning that you have two identical atoms, two atoms that are exactly the same. So if it says, like in my problem, if it says nitrogen gas, that is referring to N2, the N2 molecule, two identical atoms, two atoms of nitrogen. If your problem said that you had chlorine gas, then you would know that that meant that you had Cl2. If it said bromine gas, it would be Br2, etc. You get the idea. So for this version of the problem where you have been given the number of moles and you're asked to convert into grams, what I want you to do is start by writing down the number of moles that you have and also write the formula of the substance that you're working with. For me, it's N2. And we're going to multiply that by a conversion factor. Since we want moles to cancel out, we want the moles of our molecule, we want that in the bottom of the conversion factor, and we're trying to convert into grams. That's what the problem is asking from us, so we want that on the top of the conversion factor. The relationship between grams and moles of anything is the molecular weight of that substance. 1 mole of anything is its molecular weight, which we get from the periodic table. So what we need to do right now in order to fill this portion in from the for the conversion factor is add up the weight of that N2 molecule. So that's going to be our molecular weight or molar mass, whatever term you use, which is the weight of 2 nitrogen atoms. Now, ALEKS has a really great calculator for calculating molecular weights. There's not a lot that I love about ALEKS's calculator, but I definitely love the molecular weight feature. So we're going to go actually into ALEKS, the same problem in ALEKS. And if you click on that calculator button and pop that calculator open, and then if you click on ALEKS's calculator, that capital A that's underneath the undo button, that opens up a periodic table. This periodic table is interactive with the calculator, so when you click on an element, it actually puts that atom's mass into the calculator, and you can just keep using the calculator however you want to. So since I have 2 nitrogen atoms, I'm just going to click on nitrogen plus nitrogen, and that's giving me the molecular weight for nitrogen. And this is a really fast and easy way to calculate molecular weights. 28.013 is what I'm going to use here. 28.013, that's the mass of an N2 molecule. We can see that the moles of N2 are going to cancel out. And when we do the math on this, it's going to give us the grams of N2. I'm actually going to go back to ALEKS since I've already got that molecular weight put in there, and I'm going to multiply it by the 0.06. And my answer is 1.68. Wants this to 2 significant figures, which would be 1.7 grams to 2 sig figs. Now, like I said, there is another variation of this problem, so let's talk about that one. In the other variation of the problem, ALEKS is starting you with a specific mass, like it's going to say that you're starting with 0.06 grams, and it wants you to convert that into moles. So if you have that version of the problem, you're going to follow pretty much the same path as you did here. So you're going to start by writing the information that was given to you, but this time it's going to be in units of grams instead of in units of moles. You're going to multiply by a conversion factor. You want grams on the bottom, you want moles on top. And again, this relationship between grams and moles is the molecular weight. 1 mole of anything is the molecular weight of that substance, which we've already calculated, 28.013. So if this was your version of the problem, your conversion factor would be flipped upside down, all right, with your mass, your molecular weight on the bottom of the conversion factor, but the concept is pretty much the same thing in terms of how you would set it up. In this problem, we would be taking that mass and divide the mass provided to us, and we'd be dividing it by the molecular weight, whatever that works out to be, because I don't know that math in my head, but that's how you solve both versions of this problem.